So let's take a look at the radiation exposure from a chest x-ray. So the question tells us that a patient gets a chest x-ray that uses 10 kiloelectron volt photons with an RBE of 0.85. Now an RBE is the relative biological effectiveness, and that's to account for the differences in the biological impact of different types of radiation. Okay, so the patient has 60 kilogram mass and receive a 0.30 millisievert dose from this chest x-ray that exposes 25% of the patient's body. So we want to know how many x-ray photons are absorbed by the person. Okay, so first of all, we want the energy absorbed. So we need to put the dose in terms of grays. Okay, so to convert that, we're going to divide the dose in sieverts, so 0.30 times 10 to the negative 3 for the millifactor, sieverts, by the RBE, the relative biological effectiveness. That's 8.5. And so that gives us a 3.53 times 10 to the negative 4 gray dose, and that is equivalent to, when I think about those units or a little review, go 3.53 times 10 to the negative 4 joules per kilogram. That's energy per mass. Okay, so let's think about the mass. Now we know that only 1/4 of the person, only 1/4 of the body was receiving the dose. And so what we're going to do is say, well, we've got this per kilogram dose, 3.53 times 10 to the negative 4 joules per kilogram, and multiplying that by 60 kilograms divided by 4. We're assuming here that when we're told that 25% of the patient's body was exposed, that's 25% of the mass. Which is a reasonable thing to do. So that gives us 5.29 times 10 to the negative 3 joules. And that is the total energy absorbed by the body. Thankfully, that is not a big number. Okay, so what did we actually want to find? Well, we found the total energy, and that's good, but we wanted to know how many X-ray photons are absorbed. All right, so to do that, we want to take the total energy and divide it by the energy per photon, and that will give us the number of photons. No problem. Well, okay, the number of photons is equal to the total energy, so 5.29 times 10 to the negative 3 joules divided by the energy per photon. Well, what were we told about the photons? Well, we were told that they were 10 kiloelectron volt. Okay, so the energy of a photon here is 10 times 10 to the 3 electron volts. And we can convert that to joules because in 1 electron volt we have 1.6 times 10 to the negative 19 joules. And so that means each photon, in this case, is going to have 1.6 times 10 to the negative 15 joules. Okay, so we can bring that back over so that we have 1.6 times 10 to the negative 15 joules, and now we can get our number of photons. And that's 3.3 times 10 to the 12. It's a lot of photons, but thankfully the overall energy is not huge. So while a chest X-ray shouldn't be done without need, probably won't hurt you too much. That's it.